Good morning, cadets. I welcome you all for the next session of computer science subject. In the previous class, we have seen about the sorting method, that is bubble sort, how it exactly works and how the number of passes will be there. Outer loop, inner loop. Outer loop will keep track of the number of passes, and the inner loop will have the pair of elements are adjacent pair of elements are compared and they are exchanged if required. Now in case of insertion sorting, the second method, here if we take an unordered array and we want to make it sorted one, depending on its value with the adjacent element, okay, it will be checked where to be inserted. Based on that, shifting of elements will take place, and in its appropriate place the element is inserted. That's why it is called as shifting and inserting the element. Now, to have a best example of insertion sorting, you might have seen whenever we conduct examination in the exam hall, and at the end of the exam we will collect your answer scripts and randomly boys will give as and when they complete, and they are not in proper order. Now it's the best example of insertion sorting, because we want to arrange the answer scripts according to your class nominal roll. Have you ever observed your subject teacher after he collected your answer script, arrange all the answer sheet in the order of your roll numbers? What does he do? What he will do, basically take first sheet or first two sheets and put them in correct order, swapping them if required. Then take the third sheet and put into the correct position of previous arranged sheets. Then take the fourth, and so on, and the process continues till the sheets are arranged in desired order, isn't it? For example, the nominal number 23 will give, so I will keep it. Then nominal number 10 will give paper, so above 23 will keep. Now the nominal roll 15 will come between 10 and 23, I will keep that 15, and so on. At the end of the process goes on till all the answer scripts are corrected of that particular class in order of nominal roll in ascending. This is what example of insertion sorting. In this process, process starts from second element. The first element of the insertion, the given array will be considered as sorted part, and second element onwards all will be the part of unsorted part. Second element, that's why we take it as a key. The front element of the unsorted part, that is the second element, is taken as a key and compare with previous elements till the number is greater than key. If previous number is greater than key, we shift that element one place to its right. After all shifting, we insert key to the next position of the last element scanned. No swapping, only shifting and inserting. In case of bubble sort, swapping. In case of insertion sort, shifting and inserting. Okay. Now to have a demonstration of this, how exactly insertion sort will work, let us take an example. Okay, this is your given list having values 10, 7, 5, 1, 4, 9. Okay, and the index 0 to 5 means totally how many elements are there? 6 elements are there. Okay, next. Now this is your program or algorithm or a function, whatever you can say. As I told you, the 10 is a sorted part and 7 onward it is unsorted part. Now the front element of the unsorted part, what is that? 7. That will be taken as key. For example, you can see, you see here the I varies from 1, not 0, because we are interested in unsorted part. Therefore my first element, that is 7, will be stored as key. That is why I equal to 1 here. Next, definitely 1 is less than 6. Here the loop we are explaining. I varies from 1 to 5, right? N minus 1 means 5, and definitely 1 is less than 6 because we have totally 6 elements. Therefore we are only concentrating on these 5 elements. So 1 to 5 you want to move the value of I. So 1 is less than 6, means we are entered in the loop. Next, the 7 is stored in the key. This first element is stored in the key. Since I is 1, j will be 1 minus 1, that will be 0. And here 0 is equal to 0, and j, which is your j now? Yes, 0 is equal to 0, and j is, what was your j? J was 0, na? A of 0 means, list of 0 means 10 value, right? So 10 is greater than 7, therefore it is true. It enter into the while loop. Okay. Now, what is done here in the A loop here? Just you can see here, the 10 element is, can you see this? Initially here it is 7, it is 10. Now due to this assignment statement, your 10 will be copied on first element. Of course, don't worry about your 7. 7 already you have stored and kept in key. Now j become minus 1, that is 0 minus 1. Now in the while loop it will go back. What will happen now? Minus 1 is greater than or equal to 0, it is false. Therefore it comes out of while loop, and finally that 7 will be assigned into where? Minus 1 plus 1, that is 0, means your 7 will come in the first place. That is, you can see here, 7 will be assigned to A of 0, so our 10 will go and 7. That is how earlier it was 10 and 7, now 7 is inserted in the first place. Now your sorted parts are 7 and 10 now. Once again, when I is 2 now, the value of key 5 is stored. 2 is of course less than 6, that's why it will enter into the for loop. I is 2, key is 5. Okay. Now your j will be 2 minus 1, that is 1, and your condition check here. 1 is greater than or equal to 0, true, and 10 is greater than 5, that is also true. Therefore what will happen now? Here j plus 1, j was 1, 1 plus 1 2, A of 2 will be 1, means your 10 will be copied into A of 2, A of 1 will be copied into A of 2, means 10. 5 of course you have stored it, don't worry. Now j will become, what is the value of j now? J is 0. So once again it will check, 0 is greater than 0, and your 7 is greater than key is also true, because you are having a value 5 in the key. Okay, it is true. Therefore your 0, 7 will be copied in, yes, A of 0 will be copied in A of 1, means 7. You can observe here, 7 has come here now. Okay, now 7, 7, 10. Now I is 2, key is 5, j is minus 1 now, j equal to j minus 1. Now the loop fails, it comes out. Now here, yes, due to loop fails, this condition, this one, the 5 will be assigned to 1. You can see here, 5 will be assigned to A of 0. 5 will be assigned to A of 0. Now 5, 7, 10. Now your sorted part is 5, 7, 10, and unsorted part first element is 1. I is 3, I is less than 6, that is 3 is less than 6. I become 3. The key value in the key will store 1. Then j will become 2, 3 minus 1. Then 2 is greater than or equal to 0, and A of 2, that is 10, is greater than 1, which is also true. Now what will happen? A of 2 will be stored in, you can see, observe here, A of 2 will be copied in A of 3. Now I was 3, k was 1, j was 1. Now key is 1 and j becomes 1, isn't it? Now condition is once again true, because A of 1, that is 7, is still greater than 5. Now what will happen? 7 will be copied at the second place. A of 1 will be copied into A of 2. Now j becomes 0, 0 is greater than or equal to 0 is true, and A of 0, that is 5, is greater than 1. Therefore what it will do now? A of 0 will be copied into A of 1. See here, 5 will be copied into, yes, at one place. Now your j becomes minus 1, condition fails, loop ends. it comes out, then here the 1 will be copied in the first place. You can see here 1 will be copied in the first place. So therefore 1, 5, 7, 10. Now first 4 elements are sorted order and 4 and 9 are to be unsorted order. Now we'll pick the element 4. I is 4. 4 is less than 6. I is 4. Key's value will be copied in 4. J is 3 now, and 3 is greater than 0, and A of 3, 0, 1, 2, 3. 10 is greater than 4. True. So therefore third A of 3 will be copied in A of 4. 10 is copied in A of 4. Now what will happen? We'll see this element. A of 2 is greater than 4. True. Therefore what you can see, it will also copied. A of 2 will be copied in A of 3. Now A of 1 is compared now with key. Yes, it is greater. Therefore 5 will be copied here. Now you can check here. A of 0, 1 is not greater than 4. Therefore the condition, the loop ends. When the loop ends, then your 4 will be copied in. 4 will be copied in 1 here. Now you have 1, 4, 5, 7 and 10. These are your sorted array, and the 9 is left now. Let us check that one also. When I is 5, what will happen now? Of course 5 is less than 6. Therefore it continues. I with 5. 9 is copied in key. Okay, J becomes 4. 4 is greater than 0, and A of 4, that is 10, is greater than 9. True. Therefore A of 4 will be copied in A of 5. Now here J becomes 3. 3 is greater than or equal to 0, but A of 3, 7 is not greater than 9. Therefore condition loop ends. And what is copied here? Your A of 3 plus 1, that is A of 4, the value of key will be copied here. That's how your 1, 4, 5, 7, 9, 10. Your unsorted array is ordered in the form of 1, 4, 5, 7, 9, 10. This is how the insertion sort will work. Anyhow, I will leave the PPT with you as and when you can see. If you can see as many number of times to understand the algorithm. So algorithm or a function. Basically we use 2 loops here. The first loop will keep track of the number of passes. Once again you can say. So 5 passes are required. There are 6 elements. Therefore 5 passes. First element will be kept as a key. Then your comparison begins. Second element will be kept taken as a key, because that is the first element of the unsorted part, and the value of J and the respective elements are compared. Accordingly the elements are inserted in its appropriate place. Now when I is 6, now 6 is not less than 6, false, it comes out of for loop. So what you can see here now, when it will come out of while loop, when it will come out of for loop, you have to repeatedly see them. Now the same algorithm is written here. If you convert that this function here, you can see here, for example, what happened now? I varies from here. There we have taken for loop and while loop. Here we have taken I loop and J loop. No problem. Now this is which okay, range I. No, this is your bubble sort. It is okay. Leave it about this. And the application of bubble sort and insertion sort. What you can see here now, the bubble sort is one of the simplest sorting algorithm, but it is not considered as an efficient one because insertion sorting works better than the bubble sort. Insertion sorting has been preferred choice for smaller data sets. It does not require any additional memory. Insertion sorting is fast if the data is almost nearly sorted, and bubble sorting is best option to check a given list is in sorted order or not. So depending on the situation, depending on the purpose, we are going to select either bubble sort or insertion sort. That is how we can compare the both sorting methods. Now let us run the program and see how exactly it works. Okay, the program is already ready here. The same I have written here. Whatever we have seen in the demo of demonstration there, whatever the logic we have seen, the same I have the compiler I have edited here now. So to see that how exactly it will work, let me explain once again. Your list is 1 2 3 4 5 6 7. Here values are different. Okay, there I have taken a different values. Now here the array values are different. Now n will be the length of list. Okay, for loop varies from 1 to 1 2 3 4 5 6 7. 7 means it varies from 1 to 6. 6 means, so 1 means the first element, that is the first element of the unsorted part, 8. Okay, 8 will be taken as a key, then the j position, this while condition is checked, depending on insertion will be done, depending on the elements are shifted, this is called as shifting. Then the while loop does the work of shifting. Sometimes it may shift only one place, sometimes it may shift two place, sometimes it may shift three place, depending on the, as long as this condition is true, the shifting takes place. Once the shifting stops, it comes out and the value which we have stored as a key will be inserted in its appropriate place, that we have seen in the demo of execution. Okay, demonstration I have shown you. Now let us run this program. Okay, see here now the given list is 21 8 15 27 2 81. Now 21 will be taken as a sorted part. The first element is 8, that is compared with the first element. Okay, hence it is inserted there. Now the 15 will be picked. 15 is definitely less than 21 and greater than 8, therefore it is inserted in between 8 and 21. Now 27 is already greater than all 8 15 21, therefore it will be kept there it is. Now when it is taken 2 will be compared with 27, smaller, with 21 smaller, with 15 smaller, with 8 it is smaller, therefore 27 is shifted right, 21 is shifted right, 15 is shifted right, 8 is shifted right, then 2 is inserted here. Now the 80 is greater than all the values, therefore it is kept there. Now 1 is to be inserted here, so all the elements are shifted one place right and 1 is inserted at this place. That's how your sorted order is. Now if you want to execute another one, we'll give those different values and check now for our benefit purpose. See what was the values you had given here. Now let me give the value 10, next the value 19, the value 7, okay, the value 12, the value 9, then the value 11, then the 11 5, the value 5. Now let us run this, save. Okay, run this program. Now you see whether it is sorted or not. 7 elements, 6 passes, and as I told you, 10 and 19 are compared first. Okay, they are in proper order. What you can say, no insertion is required as far as 19 is concerned. When 7 is taken, it is to be inserted before 10. When 12, between 10 and 19. When it is 9, between 7 and 10. When it is 11, between 10 and 12. And when it is 19, the last place. When it is 5, it is the first place. Now perfectly our insertion sort is working. Okay. That's how you have to practice this, understand this logic of insertion sort, and keep on trying while executing the program. Give different sets of list and try to execute and see. That is how the insertion sort. Okay, among the linear list operations, so far we have studied about all the operations like searching, linear search, binary search, then sorting, bubble sort and insertion sort, then inserting an element to an unordered array and ordered array, and then deletion of an element using conventional deletion as well as using the Python part. So of course we have seen several examples of traversals of elements. Now before moving to the next topic that I will continue in the next class, so boys, you just go through the Python programs of all these list operations right from the beginning. Now I am going for another concept called as a list comprehension in my next class. Today we will stop here and please revise it, try to understand, and if any kind of problem, please come back to me as and when required. That is not a problem at all. Okay.